Welcome to the tutorial on FSK, Frequency Shift Keying. Frequency shift keying is a process of modulation by which frequency of the carrier is varied in accordance with the modulating wave. Let us look into the generation and the detection of frequency shift keying. The following is the circuit which makes use of two carrier signals of same amplitude 3 volt peak to peak with different frequencies, wherein voltage V1 is having a frequency of 2 kHz and voltage V2 is having a frequency of 20 kHz. This circuit makes use of two transistors, NPN transistor and PNP transistor. The signal M of t, which is to be modulated, is given as a square waveform with a frequency of 200 Hz and having an amplitude of 7 volt peak to peak. As we have seen in the ASK and PSK, the frequency of the modulating signal is less than that of the carrier, that is less than voltage V1 and voltage V2. Now let us analyze the modulation circuit in detail. When we look into the analysis of the circuit, you can clearly observe that the circuit consists of a combination of the transistors along with a summing amplifier circuit. The summer circuit is an inverting summing amplifier circuit. Now let us consider when M of t is positive, that is 7 volt peak to peak is being applied. So when M of t is positive, you are applying a voltage of plus 3.5 volt to the base terminals of the two transistors NPN and PNP. When a positive voltage is applied to the base terminals, the NPN transistor will turn on and enter into saturation region, whereas PNP transistor will turn off. The NPN transistor will pull the carrier voltage V1 to ground and act like a short circuit, whereas the PNP transistor will be turned off since it is operating in the cutoff region and will act like an open circuit. Now when you look at the voltages at the two terminals, that is point A and point B, the voltage at point A will be equal to the ground potential, that is 0 volt, since the voltage V1 is pulled to ground by the NPN transistor, whereas the voltage at point B will be same as that of the carrier voltage V2. So at the input of the summing amplifier, you have the input voltage V2 available, which is equal to 3 volt peak to peak with a frequency of 20 kHz. Now this particular circuit acts like a inverting amplifier circuit, and you obtain the output voltage to have the same frequency as that of the carrier, which is equal to 20 kHz. Now coming to the analysis as to what happens when you apply a negative voltage of M of t. When you apply a negative voltage of minus 3.5 volt to the base terminals of the two transistors, the PNP transistor will turn on and NPN transistor will turn off. The PNP transistor will act like a short circuit and pull the voltage V2 to ground potential, whereas the NPN transistor will act like an open circuit since it is operating in the cutoff region and provide the voltage V1 to the terminal point A. So at the two terminals, that is point A and point B. At point A you have voltage V1 which is available, whereas at point B you have a 0 volt. So input to the inverting amplifier circuit is a voltage V1. Again, in this particular circuit, output voltage will have the same frequency as that of V1, that is equal to 2 kilohertz. So, next, let us analyze the detection circuit. In the detection circuit, we make use of the envelope detector and the comparator. The envelope detector and the comparator has already been explained in the ASK. So kindly refer to the ASK tutorial for more detailed explanation. Now coming to the analysis of the demodulation. So we are going to provide the FSK output to the low pass filter, then to the envelope detector, and then to the comparator. So the FSK signal, which is consisting of both 20 kilohertz and 2 kilohertz, will be passed through the low pass filter, which is designed for a particular cutoff frequency, and then pass through the envelope detector and the comparator. As we have studied earlier in the ASK and the PSK, even in this case the comparator output will be a saturated value, and if the op-amp is a MUA741 op-amp with dual power supply of plus or minus 15 volt, then the output voltage that we obtain will be having a peak value of plus or minus 14 volt, which is equal to 28 volts. Let us analyze using the waveforms as to how the FSK modulation and demodulation occurs. If you remember, we had applied M of t with an amplitude of 7 volt peak to peak or plus or minus 3.5 volt, and C1 of t to have a frequency of 20 kilohertz, C2 of t to have a frequency of 2 kilohertz. So during the positive half cycle, what we saw was we obtained the frequency of the signal to be same as that of 20 kilohertz, whereas during the negative half cycle we obtained the frequency as 2 kilohertz, which is very much evident in this particular waveform. So in the detection process we made use of the low pass filter, and then the low pass filter, what it did was it eliminated the high frequency components and retained only the low frequency components. Then it was passed to the envelope detector and the comparator. So the demodulated output that you obtained is similar to that of the signal M of t, but it is a saturated value. So you obtain the peak to peak voltage close to 28 volts. Thank you.